All right, I'm Peyman Kazemian, and welcome to this presentation of Forward Network at Cloud Field Day. Today, I'm going to talk about use cases of digital twin in multi-cloud and hybrid environment. I specifically focus on how digital twin can help with more efficient and more agile operation in these environments, and also focus a little bit about security use cases of digital twin in these environments. Before I start, a few words about Forward. We are a company with a mission of transforming networks to be more reliable, agile, and secure. We are founded in 2013. We launched our product toward the end of 2017 in one of the networking field days. And just yesterday, we announced raising the latest round of financing, $50 million that MSD partners sort of led. So very exciting time at Forward. The best way to introduce digital twin is by analogy. Who here has used Google Maps within the last couple of days? Pretty much everyone. So you have used digital twin, except that Google Map is a digital twin of world roads and transit routes. Google started building this digital twin thing by putting all the static data about how roads are connected and the graph of that connectivity. They added a schedule of all the transit routes on top of that, plus some algorithm that can find what's the best way to go from A to B if you're driving or walking or sort of doing a hybrid commute. Then in order to make the digital twin more useful, they added more live data, things such as traffic condition of the roads or whether there has been an accident on the road and things of that nature. And then to even improve the usability and functionality of digital twin, they added peripheral data, things that are not necessarily related to the roads and stuff like that, but are useful when you are on the road, like price of gas or rating of restaurants and hours of those restaurants. To the point that if I type in the address of a restaurant, it will tell me that you're going to get there after the restaurant is closed, so there is no point in going there. What makes Google Map useful is broad and deep data combined with analysis that they do on top of that data, and then presenting the result of that analysis in useful UIs or through API endpoints. To the point that it becomes very useful for all sorts of use cases. Whether I'm doing a simple task like driving to grandma, or I'm doing daily commute, or if I'm a more advanced developer developing an app like Uber or self-driving, I can take advantage of that data. And the use case is so compelling that there is no going back. Who here has used the printed maps in the past decade, let's say? No one, right? You have? Oh my God.
I knew it. It was more for nostalgia.
Okay, that makes sense. So our digital twin is kind of similar to that. We started by pulling in data, config and state from all traditional networking devices like switches and routers and firewalls and load balancers. Then we expanded to SD-WAN and more sort of software-defined elements like NSX and ACI. But then these day and age, everybody has a hybrid environment. Most of the workloads are spread between on-premises and cloud. So we expanded into cloud. We started pulling data from all three major clouds, AWS, Azure, and GCP. And what I mean by pulling data is grabbing information about all the components, all the cloud components and constructs that affect how traffic is being delivered to those end hosts. Whether it's subnets and security groups, whether it's transit gateway and VPN gateway, whether it's VPC endpoints, and anything that affects delivering of traffic. So that's the starting point. Then we realize in order for the digital twin to be more useful, we have to augment that with other peripheral data, kind of the same way that Google Map did. So we started to pull in performance information, such as SNMP counters and other traffic measurements. We integrated some of the security data, such as CVE database and result of end host vulnerability scan, to the point that if a network operator or cloud operator is looking at the traffic path, they can immediately see that it's going through a congested area of network. Or if they are looking at an end host, whether it's on cloud or on premises, they can see, oh, this thing that's exposed to internet has a critical vulnerability. I need to fix that quickly. It's giving context to other types of information that are not specifically cloud or on-premises. So just like Google Map, we have broad and deep data. We support close to, at this point, 30 different vendors and close to 40 different operating systems across these vendors. These include traditional on-premise vendors and the 3 major cloud vendors. We support all sort of networking protocols, whether it's underlay and overlay, tunneling mechanisms, multicast, you name it, plus all the cloud constructs. And we have been deployed at very large enterprise networks with more than 50,000 on-premise devices. These are not end hosts, but actual switches and routers and devices in the core of the network. And we have been deployed to environments with more than 1,000 cloud projects, accounts, and subscriptions. So broad and deep data is sort of half of the story. Then the other half is, what can you do with that data when you pull that into the digital twin? And that's where Forward Network is truly unique. We expose our data and result of analysis in 2 ways. One of them is called Network Query Engine, NQE for short. What it is effectively is a vendor-neutral abstraction of the configuration and the state of all the on-premise networking devices and cloud elements presented in an open config structure. Who here is familiar with open config? So open config is kind of like an industry standard for switches and routers and firewalls and these kind of things that sort of normalize the way that these devices are configured, such that there is no sort of vendor dependency. We took that because we are coming from that networking background, and then we expanded that with a similar model for cloud, where all the cloud construct and the configuration of them normalized across the 3 major clouds, such that when you're using that data, you don't have to worry whether this is a security group in AWS or GCP. They're all sort of normalized to the same format. And then on top of this data, we have a query language that's kind of have the same flavor as SQL, where you can ask that for that data that matches a specific criteria. Let's say that you are a cloud provider, and one of the conditions you want to check is, I don't know, like in the route tables, I don't want to have a route where the next hop of that route is pointing to a down instance, because that traffic is going to be dropped or black hole, right? That's a very sane sort of sanity condition. So if you want to encode that, you can write this code one time, regardless of what kind of cloud is sitting on the background, and we will run it on all the accounts, all the projects, all the subscription, and give you the result. So that's one aspect, access to the raw data that's parsed and normalized. The other aspect is what we have spent a lot of time building, and that's computing the path of all possible traffic through this hybrid environment. What does that mean? If you think about the network, there are several ingress points to that network. At the edge, usually in the data centers, or if it's in the cloud, like all the cloud elements, they can pump traffic into this black box that we call the digital IT infrastructure. For all of those ingress points, we compute all possible ways that traffic can be pumped here. And we pre-compute that, we index that, and make that searchable to users. Why is it important? There are several categories of questions that you can only answer if you have that level of deep analysis on top of your data. For example, if you want to prove that 2 sections of your network, 2 VPCs are completely isolated or only accessible on a few ports, that's how you can prove that property. Or if you want to find the blast radius of a potentially vulnerable host, you can do that. From that host, you can find out all the places that traffic can go, all the ports that are open, and so on. Yes.
So when you're putting this data together in your query engine here, how end user accessible is that? So can I put that in front of just a non-technical security person and they can interact with that, or do we need to build a construct around this to let them dig in and answer those questions on their own?
Yes, that's a very good question. So the data is pretty much browsable. You can browse it through an explorer to see how that data looks like. And then the syntax of the query language to ask questions of that data is very simple. We actually done a lot of user study to come up with this syntax. We were having a few choices, whether we should have a Python language, for example, to query this data, or use one of the existing languages. What we find out is that many network and cloud operators are not necessarily very comfortable with those sort of more generic purpose languages. So we build something very simple that with the help of IDE, pretty much everyone can code up a query against this data. It's of the format of from this data, and like you give a path to that data, get this field, and then store it here, compare it to something else, and come up with a result. Craig will show you in the demo an example of how it will look like.
Maybe I'm missing something here, but if I start from the data and I build all the digital twin, but the data is wrong in the sense that usually my digital twin works perfectly, while I encounter a bug in the physical one and I want to test it. How are you able to demonstrate the bug, or find the solution for the bug on your digital twin that is based on a network that was working at that time, or data that was perfect at the time? So I don't know if I'm clear here. I mean, just there are glitches in the real network, and then you have your digital twin, but your digital twin is based on a state that probably is perfect at the time when it was designed or
let me answer what I understood from your question. So there are two aspects to it. One is that we are sort of relying on periodic snapshots of your digital infrastructure. So at the time of that snapshot, we build a model based on data, whether it's configuration and state, that all these elements sort of report to us. But there's always possibility that the data that, for example, a router report to you doesn't match what it's actually doing because it has its own sort of internal bugs. We won't be able to model those. We primarily focus on, but like we assume that if a device says I'm doing this, then it's going to do that. And if there is mismatch, it's beyond our ability. But majority of problems are at the config layer, not at the device issues.
Is this a virtual appliance, physical appliance, or is it a SaaS offering in one of the clouds, public clouds?
Yes, very good question. So we do have two different ways to deploy this. As you can imagine, we need to, for the on-premise pieces, we need to have access to those devices to pull in the data. For cloud, we just need connectivity to internet to issue a few API calls. So you can use our cloud offering and then deploy a small appliance on your premises such that it can ship the data back to us. Or you can just get an on-premise solution deployed in your premises, everything sort of bundled together.
Question. What cloud do you use for your SaaS offering?
We are deployed in AWS.
Okay.
So you mentioned just the connectivity needed to get into the cloud, right? But it has to go a little bit deeper in terms of like what network policies need to be there, what ports need to be open. Is it anything from a permissions perspective, like RBAC style permissions? Because if Forward needs to talk to Azure, AWS, or whatever, any VPC sitting there, it needs a way to get in, unless it's a public API and all ports are open, and right. So I imagine there has to be something specific open for Forward to speak to the clouds.
Yeah, we just use the public APIs that cloud providers give to us to pull in the data. Of course, there's permission aspect to it. Like for every cloud, there is different instructions on how to set up a read-only account for us to go and collect this data. One thing that we do for all these three clouds is ability to discover all the projects and accounts and subscriptions, because many organizations have huge number of them and I don't even know what they have. So for that, we need a little bit more permission to be able to discover them.
Got it. Okay. Makes sense.
I had a question about tenancy. So you mentioned briefly about multi-tenancy and about querying all tenants. I guess if you're a cloud service provider and you might be managing more than one end customer, how is it tenanted on your side? So could you query all tenants across your customer base if you were looking for something in particular? Or would you need to make multiple queries into kind of each of those tenants to kind of extract that data?
So multi-tenancy, like if you are like as a customer of Forward, if you are operating, for example, a multi-tenant data center, then we just need access to those, switches and routers and stuff like that to get the data out of them and then build the model. We will be able to, for example, switch VRFs and get the data from every VRF and put the data together. If you're talking about Forward sort of collecting data from public clouds, obviously we don't have access to these public clouds, like underlying digital infrastructure. We just use the APIs to get the cloud constructs and use that to build the model. And if you have multiple accounts and multiple projects, we have to switch to every one of them and collect from them and put the data together.
A quick question
Yes.
on the cloud piece and how you're storing the data. How long is the data retained within your environment, and how is that accessed or used?
Yes, that's a very good question. So it's basically zipped and encrypted and stored on a disk somewhere. Like depending on, again, like what kind of deployment you have. It is on-premise.
Let's just say we're doing cloud.
Yeah, it will be stored in AWS. Just regular files. That the data will be saved to files and stored.
Like S3 or wherever. Yeah.
Okay. EBS. How long is the data retained on your end, and can I control on how long you retain my data?
Yes, there's a retention policy. Like if, for example, you have a snapshot every hour from your environment, usually we kind of like the time machine, like the recent one, there are more of them, and then there are less as you go back in.
So you're using like data lifecycle policies to actually manage the and how long it's retained. But you're using that. Do I configure that within the settings within the software?
Yes, there are settings that you can configure. For on-premise solutions, obviously you have the control how much data you can store, depends on your availability of storage.
Gotcha. Thank you.
So, again, I have a big doubt here, I mean, especially around the security aspect of all of this. I mean, so you are asking access to, a lot of devices and parts of the network and public cloud and premises everywhere. And I don't know, when there is a huge risk that, you have a perfect copy of my data, and if somebody accesses your systems, they have access to everything.
First of all, the data, like our access to all of these environments are read-only. So the worst that will happen is you can see that data in our platform. But then we have several ways to restrict that access. We have different ways for you can integrate basically with the LDAP of your organization in terms of who you give access to. If you're security concerned and don't want your data to leave your premises, then we have that on-premise solution for that purpose. So it sort of depends on the posture of the organization.
Okay, thank you very much.
All right, so I mentioned that one half of the digital twin story is what kind of data you have. So the more deep and broad your data is, better you can help your customers. The second half is the analysis that we do on top, and I showed you some examples of some broad and deep analysis that we perform here. As a result, you have access to complete, accurate, and up-to-date model of your digital infrastructure. In order for us to make sure that these models sort of matches the reality, we have over 120,000 tests where we configure different cloud elements or on-premise devices into a specific configuration, bombard it with packets to make sure we are generating a perfect model. We can answer questions very quickly, sub-second query time. You will see that in the demo. And because everything is API accessible, we play nicely with other tools. We have out-of-the-box integration with Slack and other tools.
Have you ever had a time when, talking about the models, the first point of it, where you missed something and maybe the model wasn't correct?
Yeah, that bugs happen just like any other software, but it's not very common.
One more question on your model being up to date, basically. So you're taking those live real-time snapshots. Is there a Do you record an intended state versus an operational state?
Yes.
And saying, okay, well, this is how it's supposed to look?
We collect from the device, like in case of device, and in the case of cloud, we also have some states that we collect. This is like what the device report in terms of what state it is in, and we just rely on that to model things. We don't try to sort of emulate what the device should, like the state that the device should be, and then compare it against what it's reporting.
Right.
That's a lot more involved to do, but we just rely on what the devices and clouds sort of report to us.
So then you couldn't take a snapshot and say, well, this is my ideal snapshot. And if I have a deviation, alert me?
You can
not do that?
You can do that through a diff across time. So you say like at this time, and Craig will show you those use cases in the demo. What you can say, this is what I want from my network. And if there is any deviation, let me know. But that's more on an end-to-end level behavior, or you have a golden configuration or golden patterns that you want to follow. You sort of encode that and make sure if there's a deviation from that, you report it.
Okay.
In the interest of time, let me make some progress here. So here we have broad and deep data, broad and deep analysis combined together that create better experience for everyone in the IT infrastructure world. We have been deployed across different teams, from security teams to cloud teams and network teams, because that's one place that all of these folks can come together, access to a huge amount of data, and solve their problems. So in the rest of the presentation, I am going to show you or talk to you about some of these use cases and then back that up with some of the customer deployment stories. So on the cloud front, the most basic use case is cloud visibility. That's something that everybody need to have. You have access to live diagrams of how your cloud look like. You can use that to generate a diagram of how the paths on the cloud look like, and use that for train people to troubleshoot stuff. It's very basic visibility. Another use case is around change management. If you're coming from software development world, the best practice in software development is to define what the accepted state of your infrastructure going to be after a change. You encode that before, and then once you do the change, you make sure that the state matches that intended behavior. That's sort of test-driven development. Using our platform, you can achieve that. The other aspect is around auditing and service assurance. If you are someone that has to deal with yearly audits, you know that audit time is not fun time. In order to make that a little bit more smoother, you can encode all the criteria for passing the audit in the form of NQE checks or end-to-end behavior checks, and run it throughout the year. And then at audit time, it's all done. Like you don't have to do anything. We have several customers that sort of use us in that manner. Going to security use cases, because we have access to all the device CVEs and result of end-host vulnerability scan through integration with third-party tools, we can give you insight in terms of how to prioritize those. If you have a critical CVE on a host that's exposed to internet, you want to fix that sooner than an end host sitting somewhere in the corner of a network. Yes.
Are you pulling this from like CIS benchmarks, or using the National Vulnerability Database, or?
So the CVEs come from NIST database.
Got it. Okay, thank you.
Yep. Another use case on security is incident response. If you know that this end host seems suspicious, it may be compromised, you can use Forward to immediately find out all the places that an attacker can reach to and all the ports that are open, so you can sort of better protect yourself against possible attacks.
Is that only visibility and not isolation?
You can do both.
You can do both.
Yeah.
So you can see the visibility where it can connect to and communicate with, but you can isolate that host from a network perspective, or?
No, we don't do the isolation. Like we're not.
You're just visibility only. Okay.
Yes, but you can prove isolate. Like you can prove that this host is isolated from this other section of the network.
So the work that I do to make the changes to isolate the host, the visibility of you showing that it can't touch anything else, that's my proof.
Yes, that's your proof. And then in the process of providing that isolation, you can use that visibility to know exactly what firewalls are on the path, so you go and sort of close them.
Gotcha.
Another use case is around generating sort of the security posture matrix when the cells of the matrix shows how different resources can talk to each other, or use the path analysis to find out exactly which firewalls need to be punched open for an application flow to go through. And I will cover that in a more detail through this customer story. So this is a story about Goldman Sachs and how they use Forward in their network. There's a talk here by Josh Matthew, who is the head of network and security and GS, the link here. But essentially, the summary of the talk is that Goldman has this automated zero trust network, where at the networking layer, everything can talk to everything else, but at the firewall layer, everything is blocked. So whenever an application developer wants to deploy an application and request for a flow, there's a request that comes in that says, I want these connectivities to exist in the network. A compliance person will do a thumbs up, says that this access is okay. Then Forward analyzes the network and find out all the places that a firewall rule need to change for that traffic to go through. And then an automated software basically goes ahead and push some rules on those firewalls to allow that traffic. And as a result, the time to deploy an app is under an hour in this environment. And everything is documented because of the way that access is provisioned. And this led to them be able to deploy an application like Apple Card in about 3 months instead of a year plus that usually takes to build such application. Another example of this is how PayPal is using us. And it's kind of similar, but slightly different context. So they build a chatbot integration for all the app developers when they can come to the chatbot and ask a question like, hey, Patbot, how do I access from this application with this IP address, this other application with this IP address? And whether they are deployed in cloud or on-premise will show exactly how the path look like and whether a firewall on the path is dropping the traffic, blocking the traffic or not. So instead of them sort of getting to IT folks and ask, oh, I can't reach my application, something on the network is blocking, they can diagnose whether the problem is in the network layer or elsewhere. And I'm pretty sure for those of you that have done IT operation, IT folks are the first people that get blamed. In fact, just a couple of weeks ago, I was on a call with a contractor and they were not able to reach a service that we deployed in the cloud. They were saying, oh, there's a firewall that's blocking it, like without any proof. There's a firewall that's blocking it. It took me less than 2 minutes to open our application, type in the query and show him that, no, the traffic is fine. Like there's a firewall that's allowing it. There's a security group that's allowing it. The problem is with the application. And after a few minutes of investigation, he found out that the process that was responsible for capturing the packets on the service side is dead. So it restarted the process, everything started to work. So going from potentially days of filing a ticket for the IT team to then go and look into the ticket and prove innocence for the network, you can do that instantly with such an application.
I had a question about, before you move on, licensing in terms of how the product's licensed. Like, is it volume-based? What other features are licensable? Because you've mentioned a lot of, I guess, end users as well that might be accessing it. So is it user-based or is it unlimited users, but it's just volume-based? So yeah, how does it work pricing-wise?
Very good question. It's unlimited users. The license is based on network devices, the number of network devices that included in the model. And for cloud elements, is something like cloud credit hours, based on how many instances you have on the cloud for how many hours, and sort of charge based on that. But we don't charge on a per seat or per user basis.
And what about the retention? Like you mentioned, the retention is configurable if you want it. Years worth of retention. So is it devices plus storage or a retention slider?
Usually people are okay with the default retention policy on the app, and if it's on-premise, it's up to them how much hardware they want to throw at it.
So how deep can this go in terms of like from the application level? So for example, let's say I want to scan like a container network, or I have a Kubernetes cluster and I want to scan the pod network. Can it can it look there too for all the traffic going throughout containers as well?
It can go as deep as needed. It's whether that kind of container is in the support list of vendors, and we are increasingly going closer and closer to the edge.
Yeah.
Like we do support like Linux networking stack in the model, but Kubernetes is on the roadmap. It's not supported yet.
Oh, okay, gotcha. Got it.
All right. Next customer story is around Fortune 50 digital entertainment company that they decided that the best way to take advantage of the full capabilities of digital twin is by letting people innovate on top of it. So there's all these wealth of data. There's API that you can access. There's entry that you can access this data. So they basically organized a hackathon. And 54 people signed up across 13 teams. They developed applications on top that's reasonable for their use cases. And those applications range from finding all the printers in an environment all the way to having a change management window workflow implemented on top of the platform. And finally, the basic use case of visibility, that's pretty much something that everyone needs. Access to inventory of data, access to up-to-date map and diagram, to use that for knowledge transfer when a new employee come on board or when they want to troubleshoot something. Pretty much everyone uses for that.
So when you talk about the computation of all your different network paths, are you able to give recommendations back to a customer based on, okay, you could establish resiliency here if you did this, or you could have better optimized traffic flow if you did that? Are you kind of generating those kind of recommendations?
Today we don't do that because every network environment is different, but hopefully using that insight, they can make their own decisions.
Yeah, I have a question related to that about everything being different, because the model, like you're normalizing to a common standard, sort of, which is, so you're modeling reality, which all of the different vendors are trying to create solutions to that problem domain. So you don't quite have the same sort of denormalizing everything or normalizing everything to a lowest common denominator, it sounds like.
Yes. So
then you've also got all the vendors do have these special ways of doing things, or there's nuance in the details of specific use cases. So how do you reconcile those two aspects?
Yes, that's one of the hardest thing about this space, being able to adapt to all the ways that different vendors implement the same thing, even like comparing against the standard. If you look at like under the hood in our model, there are lots of knobs that are very vendor specific. And like we have to basically capture all those niche behaviors. So yes, we do all of that, but still we normalize that into a vendor agnostic model that has a lot of knobs.
Can you deploy your own models, or is there a appetite to allow that in the future around if you had something really bespoke that you needed to do as an organization?
It's really hard to do that, but we are thinking on that direction as well, to sort of open up the model to everyone to develop their stuff on top.
So I guess kind of on that development bit right there, when I start thinking about this and putting this in the hands of engineers, and I start thinking about, okay, automation and CI/CD pipelines, is there a way to model a future state and test that future state and verify it?
That's on the roadmap. We are working on it, yes.
Okay, cool.